Welcome back. Concept 5, concentration and solubility. So let's revisit what is the solution. Well, a solution has two components. There's the solute, right? And that's a substance that's dissolved. It breaks into smaller particles that cannot be seen. And then we have our solvent, the substance in which the solute dissolves. So example that we often use is salt water. So the salt would be the solute, which dissolves in the solvent, which is water. And then more often than not, you've heard that water is the universal solvent. And again, a solution is a homogeneous mixture. So again, homo, that prefix meaning one. So homogeneous mixture in which one substance dissolves into the other or another. So here we have a quick little, I guess, illustration to help you guys out. So we have sugar water in solution form. We can see that the water is the solvent, these circular particles, and then the 1, 2, 3, 4, 5, 6, so the hexagonal particles are the sugar particles, which are the solute. Okay, so here I've given you some examples of solvents and solutes. So sugar water, well, across the board for our solvents, water is solvent. It's not always going to be water, but more often than not, water is a common solvent that's used. And then for our solute, we have sugar for sugar water, juice crystals from juice concentrate, and then for tea, we have the actual tea leaves. As I said before, water is the most common solvent, and water is often called the universal solvent because it can dissolve most things. And as you go further along, you'll learn that's because water is polar, so there is a negative side and a slightly positive side to that molecule. Oh, and here we go. So, why is water such a good solvent? Well, water molecules have a polar arrangement of atoms. One side, which is the hydrogen, has a positive charge right here. So the hydrogen essentially gives up an electron or shares an electron closer to the oxygen. Because electrons are negatively charged, it has a slightly negative charge. So on the single water molecule, we have a slightly negative charge on this side and a slightly positive side charge on this side. Because of this, water can be heavily attracted to many different types of molecules and breaks up forces that hold these molecules together. This breaking up is called dissolving. Okay, so here you have different arrangements. Okay, so I believe I have a digital copy of the workbook for you guys, but essentially there are some different solutions for you guys where you have to name the different solvents and solutes. Here are your answers for you. So with coffee, again, across the board, typically water, juice, or tea is your solvent, and then you have your physical particle that you are either uh, dissolving or steeping to a degree that becomes your complete solution. Okay, here are some additional practice questions for you guys. Looking at solubility. So solubility is a measure of how easily a solute dissolves into a solvent. Specifically, it measures how much solute will dissolve in 100 grams of water. It should be milliliters, but yeah, it should be how much solute dissolves in 100 milliliters of water. What makes something soluble? The solute is able to fit between the spaces of the solvent. The solute particles evenly distribute and dissolve into the solvent spaces. Okay, so again, we have a sugar particle which is able to dissolve or break up and fit in between the water particle molecules. What makes something insoluble? So when the solution particles stay together and do not go into the spaces between the solvent particles. So here, oil, you can kind of mix it up and you'll get kind of blobs of oil in water. But essentially with oil, it will separate and it will kind of form a single layer over time, an oil layer and then a separate water layer. Okay, concentration. Hopefully that's what you're doing. So concentration is the amount of solute dissolved in a solution, or how much solute is in a certain amount of solvent. So an example is if you dissolve 3 grams of sugar into 100 mils of water, the concentration of the sugar in that solution would be 3 grams per 100 milliliters. The formula for you guys is concentration is equal to the mass of the solute, grams, divided by the mass of the solvent. Okay, so here we have a couple of visuals for you guys. So concentrated, a solution with a lot of dissolved solute has a high concentration and is called a concentrated solution. A dilute solution is a solution with a small amount of dissolved solute, has a low concentration, and is called a dilute solution. So essentially here we go, we have a spectrum for you guys, or a continuum. We have a diluted solution here, and you can see it being indicated with the food colored dye. So this one's fairly diluted, has a slight pink tinge to it. And then as we increase the concentration, it becomes a dark red, right? Looking at the example above, we have only a little bit of salt, so it's diluted. As we add more salt, it becomes more concentrated. Okay, comparing concentrations. To properly compare concentrations of two solutions, you need to have the same amount of solvent on the bottom of your measurement. So you need to have the same denominator, a common denominator. So a little bit of math coming in here, right? If we have a denominator of 100 mils and a denominator of 300 mils, create a common denominator. So for this example, making both concentrations out of 300 mils, right? So we can multiply them both by 3, the numerator and the denominator, which gives us 12 milligrams over 300 milliliters, which then means that this one, or the 4 grams per 100 milliliters, is more concentrated, right? Because 12 is greater than 10. Again, similar example. So the first thing you need to do here is get a common denominator. So you have a denominator of 1,000, a denominator of 500, and a denominator of 10. What I would do is I would multiply the second one by 2. So that would give us a denominator of 1,000, right? 500 times 2. And then the bottom one, I would multiply it by 100, and that would give us a denominator of 1,000 as well. Here we have a denominator of 30 as the largest denominator. So I'd multiply the top one by a factor of 3. The second one I would multiply by a factor of 2. The third one I'd leave the same. Okay, we have a denominator of 500 as the largest value. I'd multiply the first one by 5. The second one I would multiply by, oh, I don't know, let's take a look. Well, 25 times 4 gives us 100, and then we need 5 more, so 4 and 5, so I can multiply it by that much. Saturation. So saturation is a measure of how much solute is dissolved in a solution compared to the maximum possible. So we have an unsaturated solution here because we can still fit more solute in this solution. And on the right-hand side, we have a saturated solution because we have essentially put as much solute as possible. If no more solute can be dissolved, we say that the solution is at its saturation point. Okay, and then obviously there are supersaturated solutions, which we'll talk about in a bit. Okay, so an unsaturated solution we just spoke about, there's more room to dissolve solute. A saturated solution, no more solute will dissolve, and then a supersaturated solution becomes unstable or becomes a crystallized form once it cools down. So when you change the solvent by adding heat to increase the spaces and dissolve more solute, once it's cooled, crystals will form. So this is actually how you do rock candy. This is how simple syrups are made, um, and various other substances. Um, I'm not sure what resources you have at home or at school, but doing a DIY rock candy lab is a great way to look at supersaturated solutions and look at crystals that form. Maybe I'll post the video on Google Classroom for you guys. Okay, I have a concentration lab that you guys can go through. The procedures here, you're more than welcome to do this at home or at your schools. Include a chart for you, a few practice questions, and then we get to the main idea, so the factors that affect solubility and the rate of dissolving. Okay, so one, changing the surface area, right? How does that affect the rate of reaction? Two, changing the solvent temperature. Well, we kind of alluded to increasing the temperature, and that creates a supersaturated solution. Three, changing agitation. So agitation is stirring or mixing, right? How does that affect the rate at which a solute dissolves in a solvent? I've given you some values. 1 stir per second, 1 stir per 5 seconds, 1 stir per 10 seconds, right? The less we stir, the greater the time it takes to dissolve, essentially. Okay, so here are 3 ways that you need to know that we can change the rate of dissolving. So changing the temperature, if we increase the temperature, we increase the speed of particles, we increase the spaces between them, we increase the dissolving rate. If we change the surface area, we expose more solute to the solvent, more available solute for solvent access, which thereby increases the rate of dissolving. And then 3, if we agitate it, we increase the speed of the particles, we create more chances for the solute and the solvent to bump into each other, and these collisions thereby increase the dissolving rate. And there you go. So that is lesson 5 for you guys on looking at the rates of reactions and looking at how we can increase dissolvent rates. There should be a lab on Google Classroom for you guys that you guys can do on your own. And like I said, if you are interested in doing rock candy at home, I'll post a video for you guys. Take care. Bye-bye.